So we got a little nifty drone here. All right, Neil, tell me about this. What is this?
All right. Well, first of all, the name of our company is Catalyst Machine Works, and we have been in existence for about 1.5 years.
Yeah.
This is our
What is this?
5th or 6th rendition of a drone. This is the frame, so this is like the bare chassis.
Yeah.
Say.
No batteries, no props, no engines.
Nothing
Yeah.
on it. Just the bare carbon fiber and aluminum. So we've been going through some prototype testing, actually extensive prototype testing.
Yeah.
And this, what I'm holding, represents the first, production run of this system. And so I put it together just now with my business partner. We were just testing out the fit, the finish, everything that goes into a system like this. Make sure everything fits right.
Yeah. It's got a name though, right?
The Stig.
The Stig.
So I don't know if you guys have ever watched Top Gear, but Top Gear is all about cars and going very fast. It's pretty well known in the UK, but if you're a gearhead, you've watched it.
What is special about this design?
What's special about this design is this right here. So in a FPV racing machine, what you have is a lot of thrust heading in this direction. And so what you want to do is you want to minimize the amount of material that's in the way of the thrust so you have a very efficient frame.
Right.
This is currently the most efficient frame on the market. And so we have the smallest amount of carbon fiber and material in the way of the thrust.
It's like each one of these little, literally you've turned each one of these little struts into a wing of sorts, yeah.
Right, so the way that typical racing drones have been constructed is that these plates were turned 90 degrees, and so you have a big plate that's impeding the line of thrust, but what we did is we flipped them 90 degrees, and then you have this.
Right.
Right. So that's it. That's the theory, and our product testing and our flight testing has been very exciting because this thing is just unbelievable in the air.
Yeah, tell us how fast this thing can go, like when you're really putting it through its paces.
We have got this thing up to 109 miles an hour, right? So
John was telling me last night, like you weren't even really trying to break records and exceed.
We weren't even trying. I mean, we went out to our own top speed competition, and we had put together a 250 size frame, and we had it on 6S and all that, high voltage and high RPMs. It didn't do as well as we had hoped, but we decided to go ahead and try this and see how it do in the top speed running. And we grabbed a 5S pack, a 5-cell pack from a friend who was there that we had actually met there at the race. He let us borrow it, and we went to see what it would do, and lo and behold, the thing went 103.9 miles an hour, 104 miles an hour. And then we actually ran 109 miles an hour with it, but we weren't filming, so we're not claiming that, but it did go 109 miles an hour.
Right.
And so what we're going to do is we're going to take this one, and we're actually going to... There's some drunk people over there. I apologize. Wasted.
That's all right.
It is 4th of July.
This ain't like no serious video. You're just showing it off.
Hey, so that's it. We're gonna try and see how fast we can get this thing to go. Put some high potency motors on there and ESCs and all that goodness.
Oh, okay, so basically when you got it up to 109, you didn't have the best of the best motors and that kind of stuff on it.
We had good motors. We had X-Nova motors, and we had good props and all that stuff. But it's just there's a lot of variables that go into making something go fast.
Yeah.
Probably one of the biggest ones is high KV motors and the right prop. We didn't have the right prop out there, and we didn't have enough speed on the motors.
So this thing, you haven't seen this thing go as fast as it really can go.
No, we think we can break 120 miles an hour with this thing.
Wow.
Absolutely.
Wow.
Yeah.
And tell me, like you said, this is made out of carbon fiber and aluminum. Where do you source your material? Like who makes the actual?
So everything that we have cut is here in the States. All of the design work is done by me, and then we have some select shops here in town that do the cutting for us. So.
Okay. And so everything's sourced locally, basically, is what you're saying, right?
Yes.
All right, cool.
And we do have some vendors that are out of state, but we try and keep it in the same state just so we can get things in quickly.
And if you wanted to have, like, let's say you're really into this, like you've watched this video and you're really impressed by what you're seeing. If you wanted to obtain a Stig?
Right.
Keeping in mind this is the first production run, so we're in production now. If you wanted to obtain a Stig, how much is it, and how do you get it?
Well, the frame is $145. We got it for pre-sale right now on our website, catalystmachineworks.com, and we sell everything else that you need to build the thing. All the motors, ESCs, the transmitter, the receiver, the flight controller, the power distribution board. It's a whole list of things that go into making the finished product. It actually looks quite a bit different from what you see now when you get it all done.
Right, yeah, I imagine.
But yeah, we sell everything you need to get one up in the air.
So it's almost kind of a do-it-yourself project to build.
It is. I mean, we're gonna sell ready-to-fly systems, but that's going to be a little bit of time. We need a little bit of time to do that. But yeah, we sell everything you need. And the big part about our company is that we help you to get it up in the air. It's pretty complex. That's no joke. It's just a complex system. So it takes some know-how to do it. If you're just getting into it and it seems daunting, we have the knowledge and the people to help you get through it.
Word. All right.
Yeah.
Awesome. Well, thank you very much, Neil. I appreciate you taking some time to talk with me about it.
Okay.
Excellent product you got right here.
Thanks.
Uh-huh.